Okay, so I'm very happy to introduce Professor Matthew Larkum from Humboldt University of Berlin. He came to visit primarily Lucy Palmer in Melbourne and to collaborate with this kind of dendritic patch clamping kind of collaboration, I suppose. But he's recently actively publishing various kind of theories and also reviews and the proposal on consciousness based on the dendritic function. So, but first part of this talk today is going to be this controversial thought experiment paper he published a couple of years ago, which would be very interesting to us. So please go ahead. And as usual, I asked Matt the talk to be around like 30 minutes, 25 minutes. And then after that, it's going to be Q&A discussion.
Excellent. Well, thanks for the invitation. I'm glad to be here. Actually, I'm partly here to visit a former president of the Florida Institute. But in the meantime, I'm really happy that we finally get to meet up, and I'm looking forward to the discussion. We're a little bit apprehensive about the format, so let's see how we go here. Partly because this came out of an idea which had been buzzing around our lab when we started talking about this thought experiment maybe a decade ago, a little bit over a decade ago. It was due to a postdoc in my lab. So I don't consider myself a philosopher, but and by the sounds of it, we're all in the same boat in terms of being neuroscientists being thrown into this problem of trying to understand consciousness. And we actually designed this thought experiment for neuroscientists, not for philosophers. So it's probably the right audience. Well, I'll put something on my screen again. The host has spotlighted your video. Is that all right?
Yeah, I made you the spotlight.
Good. Just before I do it, now asked me what I wanted to talk about, and I chose this of two things, because there was another, we recently were publishing something which could form in a way, I could imagine branching off more into this discussion, but it doesn't have to be, but just to flag it that we were also recently talking about essentially what the recent developments in AI mean for consciousness. But anyway, that's not what I've chosen to talk about. I'm just using this video here, which comes from a former postdoc of mine, Masanori Moriyama, who's now got his own group at Recon, just to kick off why we thought it was timely and why we wanted to talk to neuroscientists. This is just one of many examples in today's world of neuroscience of pushing at recording from lots and lots of neurons simultaneously. Of course, there's the Brain Initiative in America, which its explicit aim is to record from as many neurons as possible, with the kind of, at least in their more ambitious moments, the claim that we may soon be able to record from all the neurons in the brain. I don't know how realistic that is, but certainly we thought that it was necessary in a world where people are actively talking about pushing the limits of how many neurons you can record from at once, a discussion of what you would do if you could record from all the neurons at once. What would that mean, and what would we learn, and with relationship to consciousness, would that actually bring us to where we need to be? Is that what you need to do, and what are the consequences of that? And just before I get into it, I think there's an unwritten assumption in, or let's say it's a pervasive implied assumption for neuroscience and on the part of neuroscientists that basically the action potential is really central to what neurons do, and so I find myself trying to explain what I mean by this, and in some sense I think you could reduce, if you're going to kind of do some ultimate reduction along the lines of a Turing machine and try and work out what it is that the brain is doing, I think in some sense, we're assuming that you could represent what's going on in the brain by saying what the activity of all the neurons is. I think certainly the assumption of the brain initiative and on all the kind of 2-photon imaging experiments you see and the neuropixels data we start to see more and more, there's an implicit assumption there that knowing what the firing of the neurons is somehow really central to knowing what the brain is doing. And I think very often I'm talking to somebody who doesn't even know what other options you would have in that. So that's how central I think that assumption is, which I think comes with the implied assumption. The best way I can represent this is that you could basically instantiate what's going on in the brain by what boils down to a spreadsheet that tells you which neurons are firing, as in this here. You can imagine some really long vector saying these are the 100 billion neurons and this is their activity state. And of course, this would change if you update those states, and then you'd have to know how they're all connected. But I think that's also an implicit assumption that if you knew those facts, and maybe the third fact that you might want to know is how these are going to change over time. Let's just say not just what the connection strengths are, but some function for changing the connection strengths. You know, there's obviously a lot of other facts that we know about the brain, glial cells, and all sorts of, you know, the way it interacts with hormones and blood vessel or distribution. There are different things we could talk about, but I think to a first approximation, most neuroscientists assume that if we had these three facts, the state of all the neurons at every time, the connectivity between the neurons, and whatever the rules are for changing the connectivity, that we've done it. I think that everything else is a detail that it's not going to get us further to understanding things like consciousness. So that if you buy that, I'll just go through this because I want to save some time. But these are essentially the facts in summary. And if you buy that, then this is the starting point, I think, for the thought experiment that I really have to attribute to Albert Gidon, who's a now senior postdoc in my lab. We eventually, in the publication, we got joined together with Aru, had some more experience. From a philosophical point of view, we were really grateful to have been able to collaborate with him. He also worked in the lab for a couple of years and comes through a history of looking at brain activity at the scales perhaps you're more used to. And because my lab started from single neuron recordings in his own, and more recently gone into multi-cellular recordings. So as I say, Albert really is responsible for the germs of this idea, and he brought it to our lab's philosophy club, which is kind of where we talk about things we otherwise don't dare to talk about. And he brought this thought experiment to that. And at first I thought this was basically just a rerun of things I'd always heard before. But the more I thought about it, the more I found it challenging. And just a spoiler alert, I actually don't know what I think should be the answer to this. I'm still struggling with the answer, but maybe you guys are not. So we'll test that. It's basically a thought experiment about what you would do if you could record from every neuron in the brain. And also it assumes not just record, but manipulate. So first approximation, you're imagining, since we're coming from this tradition, I know Greg's in the audience, so he'll understand this. Imagine you could do a whole cell patch clamp recording from every neuron in the brain. And we're not worried for the purposes of this thought experiment that it's not feasible to get that many glass pipettes in the brain. Suppose that it was feasible, and then where would we go with, you know, what could we learn and what would this mean? And so the first step in this thought experiment is to use all the recordings you've got to record the activity. So another assumption going on here, and one that was really interesting to me, because we work on dendrites all the time, is that this is recording from the cell body. And actually, since Greg's in the audience, I can attribute the I think he's responsible for the condensing this whole notion of what we're doing with dendritic computation and integration in cells to a really fundamental concept, which is that for most neurons, the final side of integration, as Greg put it, is the axonal initiation segment, which happens in most neurons to be quite close to the cell body. And so it's kind of an accident that is the case, I think, because God could have put the axon anywhere and he put it coming out of the cell body. So, and the cell body is easiest to put an electrode on. So we're in this space where if you record from the cell body, you're so close to the final side of integration that you basically know what the output of the neuron is if you record from the cell body, and there's not much more to say. So we're assuming that also in this thought experiment. But as you'll see, I'm putting it in extremely simple terms, and this is a thought experiment that you can extend the boundaries. So eventually, I don't mind if we start talking about what's going to happen if you go into the dendrites. And the first step in this thought experiment is to record the activity of the brain during what has to be a conscious experience. So you need a subject who has some experience. The way it's formulated in the paper is a woman who has to press a button when she sees the go on the screen, and she has to report as part of this that she's had a conscious experience. So you have to take a report in this sense, but you can actually flip this and do it, make the subject you. So you or somebody else is recording from every neuron in your brain while you have the conscious experience. And then, of course, you own this in some sense, and the result of this thought experiment, which, although it's not practical and it's really hard to imagine how we would do it, is an extrapolation type of argument. So I can't see an in-principle reason why you couldn't be the actual subject of this experiment and find out for yourself whether brain activity causes consciousness. Okay, so nonetheless, this is set up so we're the third person, we're accepting this person's report. Nevertheless, they have a subjective experience and they have to affirm that. Okay, so pressing the green button means they did that. That's the end of the recording, if you like, and now you've got essentially a tape of all the activity of all the neurons that went on during that process. So there's a diagram of what that is. Okay, so that's setting it up. Now, the next part is a replay of all the activity. And so this is basically taking all your electrodes and injecting the necessary current into all of the neurons of the brain and letting it go. And in this, so you could just leave it at that. We wanted to be a bit more precise about how to say that. And so another thing you can do with once you've got voltage clamp control over a cell is not just say fire now, but actually follow the random walk of the membrane potential at every moment in time, including when there's a spike, the exact shape of the spike, and then coming back for repolarization and so on. So we include that in the thought experiment. And so here, every neuron, the cell bodies of every neuron does exactly what the cell bodies of every neuron did in terms of membrane potential at every instant in time during this replay. So if you were, one way of looking at this is if you were a third person trying to work out, a third neuroscientist trying to work out what's going on here, and you put another set of 100 billion glass pipettes on the cell bodies, you'd have no idea whether this was a replay or whether this was the original. So from your point of view, and in particular, I think in the end, from a causality point of view, you don't know why the membrane potential is doing what it's doing. If you're the third neuroscientist recording membrane potential. Okay, and so now every neuron does everything that it did before, and this is a multi-step thought experiment. So you have to ask yourself whether you would guess or intuit or predict that that the woman would have the same subjective experience that she had the first time, which was completely untouched by your manipulations, but was just allowing neurons to do what they normally do. And it's really important for this part of the experiment that there's no other manipulation. So all the causality that was there in the beginning is still there, in the sense that action potentials still go down the axons, they still cause the release of transmitter. This transmitter still has its effect on the other side of the neuron. But there is something going on here. So the breaking causality is that no matter what happens, and if there's any noise or there's some difference that happens the second time, you prevent that having any influence on the final side of integration. So the final side of integration sees exactly what it saw before, but all the other causalities in the system. And you have to ask yourself whether there would be any subjective change. And of course, I like to say that, you know, if you're the subject here, and in principle, as I say, it's in principle feasible that you would do this on yourself, and so you'd suddenly find out. Nobody else could really know, but you would find out if when this replay happened, you actually experienced the same thing. And in that context, I think we're assuming that since most people claim that brain activity causes consciousness, and because the central notion of brain activity seems to be the action potential, that most people would feel compelled to say, yeah, all right, so that experience would occur again. But not everybody. And it's, I guess I was at, now actually last year at the IIT workshop in Venice, where I think most people in the IIT world wanted to jump off at this point. And I don't know how many people here are IIT advocates or not. But we can come back to this point, and it's already, you know, I think it's plausible that you jump off at this point. I also think it's probable that most people don't. Certainly the functionalists, computational functionalists, I don't think want to jump off at this point. Okay, and so we can take this another step. And
Do you want to ask a vote right now?
Yeah. Actually, who does want to jump off right now?
I mean, that subject will lose consciousness.
Yes. So the question is, who? Well, we can put it either way you like. Who thinks that this step you would lose consciousness?
Just to clarify, during the replay.
Yeah.
Just put your hand up.
Yes. Just without stating much.
Well, yeah, maybe. Is that a maybe?
Yeah, so I think yes, but my intuition is no.
Yeah.
Not that, no, you would not.
No, you would not lose consciousness.
Yes. Certainly that was my intuition too. Okay, so we can just drive this another step then. And now we can start playing more with the causality in the system, because we're going to say, well, all right, so where is it? And in the next step, we start disconnecting synapses. We did a kind of complex way to do this for reasons that I'm not sure are really important in the end, but we wanted to get us some possible objections you might have to the way we were disconnecting neurons. It's not too impossible. Here we did it with an optogenetic disconnection and basically reconnection. So in other words, we want to take away the influence at the synapse from one neuron to the other. I think to a first approximation, you can just imagine throwing in CMQX and APV and doing away. You can actually also, there's a kind of missing step here, which when we first formulated this, which we also looked at, you could imagine throwing TTX into the brain, or doing some fancy way to take out the ability of this initiation zone, the place where the action potential is generated, from going down the axon and getting to the synapse. Both of these steps are doing something kind of similar, which is taking away the inherent causality in neurons signaling to each other.
block the receptors?
So we're blocking the receptors, and but as a preliminary step to this, which is a little bit conceptually easier, imagine just stopping the action potential from going from the initiation segment down to the end of the axon. In other words, you generate the activity in the neuron per se, but let's say if you put TTX in, you've got no sodium channels, it would just die along the axon, and it wouldn't get there. So it wouldn't have the causal influence on the next neuron, bearing in mind though that since you've recorded from every neuron, and since the cell body of every neuron does the random walk that it did before and fires the action potentials where it did before. So this should be irrelevant, one thing. Or actually that's the question. Would this be irrelevant? Let me just do it the way we actually published it, just so that if either of these, if you're a bit scared about dumping poisons into the brain, which was it's my simplified version, then you could do something really complex like this, which would be a really, the really surgical way to leave everything else intact, but take away the influence at the synapse of the release of transmitters and so on. So in other words, you disconnected every neuron from every other neuron, but you're in control of every neuron, and you're making every neuron fire exactly the way it did before. You could argue at the step before you ignore the influence, and this step you ignore the influence plus you take away the influence. So there was no influence to ignore anymore. And so now you have to ask yourself, okay, does that change things? And okay, throw it up, and does it change it? Does anyone feel that changed something in this thought experiment? And at this point, if you thought it was conscious the step before, you have to say it wasn't conscious at this thing.
So just to clarify, what you're doing here is there's no communication between the cells, but you still stimulate the action potentials.
Yeah.
But the action potentials of one cell is not caused by the other.
Yeah.
It's just like, oh.
Exactly.
Okay.
Doesn't feel like it changes anything. It doesn't feel like it changes anything. It feels like it's the same between the previous state, even though it doesn't feel right.
Like IIT people would be like, no, this is not a conscious experience.
Right. That's IIT is very much relevant here because they're talking about causality.
I want to jump out.
You want to jump out? Specifically,
You should have jumped out last step.
Like,
it's Angus, is it?
yeah.
You want to jump out now, but not before, or you were unsure before?
Before, my intuition was potentially they're still having a conscious experience, but I think based on IIT, which is where I'm from, I think probably they'll say you don't have a conscious experience. So that's why I thought no.
Yeah.
That's why I thought no, they don't have a conscious experience. But my intuition is still maybe they have some experience.
Yeah.
But here I'm more inclined to, my intuition is just they probably don't have experience.
I mean, for the people that jump out early on, of which I don't see anyone at this point, but for the people who want to jump out at step one challenge to them is, well, we know that neurosurgeons for over, well, many decades, I don't know how long now, that have been stimulating the brain often as a diagnostic tool to see, and they dialogue with the patient and say, what do you feel when I stimulate here? And I mean, as far as we can tell, and I guess there's plenty of people who have first-hand experience, if someone stimulates your brain, you do have an experience that's the result of the influence of stimulating your brain. Of course, that's not quite the same as taking every neuron in the brain and stimulating. So there's space there.
I mean, it's pretty, like Penfield in the 50s was showing what you're describing, but this also reminds me of when you do engram optogenetic experiments, you record the precise neurons, you floss replay later, they show behavior like they've had the same experience again. So it's pretty much exactly what you're describing.
Right, right.
But I'm not
talking about Tonegawa and
exactly.
Yeah.
I'm not a functionalist, but I still think they're conscious at this stage.
Okay. So good. I'm go on. The next step, which is basically this is a multi-part step, but time constraints. So we're going to start actually cutting up this to explore some other issues. And well, let's just go through it. You can, on the one hand, you could one way you could do this is, let's suppose it's a visual experience, as it was in her case. She's viewing a screen. So you could imagine getting a scalpel and going around the line of V1 and taking out the primary visual cortex, in the sense that you cut it physically off, such that the axons that connect from V1 to anywhere else are gone, or at least cut, severed, without doing anything else. So not moving it, not taking it out, but leaving it in place, and actually something like a frontal lobotomy, but a posterior lobotomy or whatever. And now you leave all the electrodes in place, you rerun the experiment, you replay everything. So everything is, and anyway, the step before we disconnected all the neurons. So they weren't connected anyway. We just cut the axons now. So the question is then, does anyone want to jump off at that stage? Is this critical that they actually physically reconnect? And then you can do different kinds of resections. You could actually pull the primary visual cortex somewhat out. You could distort the location of it. And when I heard Albert first suggest that, I'm like, what the heck, you know? But his point here was that you could be talking about, let's say, larger macroscopic electrical field interactions or those sorts of things. And there are plenty of people in neuroscience who would say such a thing. And so they might want to say at this point, yeah, now the field interactions have changed because you've distorted the actual physical relationship between the primary visual cortex and the others. So you're free at that point on those grounds also, I think, to say something's going to change then, but not before. I'm not seeing anyone at that level with it.
If I'm not sure if this is your, like, I don't know, you would know, but then if it is like field interactions, would they not be mimicked by the replay function perfectly mirroring the kind of charge curve?
Yeah, that's a
each
good
cell
point.
body? Like,
That's a good point. And again, it comes down to what you mean by causality, I think. I think what you would say is if you were now the third party neuroscientist, but your tool was a, say, local field potential device that was detecting, you would see differences. So you would suddenly say, no, that something just changed. Like if you had a local field electrode somewhere in V1 and V1 was displaced by something, you'd suddenly see some change and you would want to say, well, that's not.
I'm tempted to jump off because I see where you're going.
Yeah.
I think it's Adam Barrett at Sussex, for example, has an electrical integration theory of consciousness, which is like consciousness derives from electric field integration. So this would violate that.
Thanks,
Yeah. But so you could jump off here. I mean, in the end, it's we're going to the end wherever you jump off here. So and of course you can resect in a different way, which is let me just go through this. You could put the whole thing in a jar. It could be then the classic brain in a vat experiment. And of course you can do the ultimate, which is you could dissociate the whole brain, give out each neuron to a neuroscience lab around the world, give them a patch clamp setup, tell them when they've got or how they've got what they've got to inject into their neurons, and you could run the whole experiment in all the labs in the world where all the neurons from somebody's brain did exactly what they did before from the point of view of the electrical activity in the cell body. And now who wants to jump off at this point if it's dissociated neurons? So that means most people here are sticking to it.
Yeah, I don't have a good reason, but I can't imagine that. I mean, there are already patch clamp experiments ongoing on the world right now, so technically.
They're all alive.
Yeah.
They're all conscious. Right. This is very disturbing, I think, to get to this point. And yeah, I'm at this point also saying this doesn't feel right. I've got I did computer science at university. I was kind of in that frame of mind. I would have gone here, I think, before I became a neuroscientist, I would have said, well, okay, well, that's what it says, you know, I've got to say yes at this point, that all the neurons doing all these things all around the world are doing the computation that was done before, and therefore it's conscious. But I don't feel so comfortable, I agree, doing that. I don't want to jump off here, and I didn't want to jump off at the front. And I guess the point is, I don't know, in summary, I don't know where I should have jumped off. And I'm still not sure where I should have jumped off. So from my point of view, the instructive thing here is just to discuss it. I don't want to tell you what you ought to think. I just think it's a good thought experiment because so many people don't know where to jump off. We didn't know where to jump off. I've seen this actually, although I'm sure that Albert came up with this of his own free will. We came across several other instances in writing this up of people who've had almost, well, one was just identical, and others are very close. And so I think this is kind of a natural thought experiment, and certainly one in a world where we're all just recording activity from neurons to ask ourselves. Now, how much time have I used at this point?
It's fine. I think it's probably a good time to.
Yeah, I have a follow-up to those experiments that add something more that we could start the discussion or.
Yeah, maybe shall we do that then? To have a 4-minute break right now, and then maybe you can we will take some comments or questions first, and then if we still have time, maybe you can talk about the second part. Yeah. All right. Anyone? I mean, maybe then I'll just give a little bit of summary of what you did. So it's great that you made this transition of dropping off step into this kind of gradual ways, because many people tend to say something really vague, right? Like some kind of function such as a recurrency is correlated with consciousness, a global workspace is a correlated with consciousness, or another case is even more vague, like consciousness is something that emerges from what? I don't know, but you kind of dissected out at which part this each of these assumptions falls. So I really appreciate this thought experiment, and yeah, I want to ask you guys what is your sort of the opinion, comments? I mean, IIT's viewpoint maybe something that you want to first represent, or.
And I just wanted to ask first of all, how the proportion of people, how they jump off, where do they jump off normally?
I jump off at step 2.
Step 2. Step 2?
That's upset. Yeah, I can't remember what the exact numbers were. But most people don't jump off at step 1, although there's a healthy number. There's like a spike at step 1, but it's the minority.
I'm interested in if you're dropping off at 2, why don't you drop at 1? Why?
I was thinking maybe it would be a different conscious experience.
Because neurotransmitters aren't involved, or?
Probably.
The quality changes.
Yeah.
Yeah.
You mean?
Yeah.
Is it like an analog versus digital sort of debate? Like if you're replicating charge digitally versus this sort of granular.
I guess yeah, you make a point, because at first I was feeling like, oh, you just replay it, then I guess that's fine kind of idea. But then now I think the key difference between the replay and the original is that the action potentials do not come from genuine causation.
Okay.
Causal relations. I guess my attitude is similar to Angus's.
Yeah.
But then not yet.
By the way, just before you go, so I think the way we formulated it, certainly from my perspective, I'm more interested in the question: Are you conscious at all, as opposed to is the experience identical? Is this a binary thing, and do you lose consciousness at any point? But you could reframe the whole experience, the whole experiment in: does anything change in the quality of it?
Yeah.
You know,
So,
when
like-
you're doing all these operation across all the possible neurons and all possible connections, right?
What if you like retooled it slightly so that instead of measuring like action potential, you measured like type and amount of neurotransmitter released, and then you had an ability to release it right at the synapse in exactly the same fashion as they did originally. And instead of replaying by electrode, you replay by chemical release. Is that then the same? If you jump off at 2, wouldn't that then fix that? And you're-
And this kind of begs the larger issue, because you can keep on going like
Yeah,
this.
yeah, exactly.
What if, I was kind of expecting Greg to ask, what about the dendrites that are not going to be doing what the cell body's
Yeah.
doing? And of course you can say, well, okay, let's use an optical clamp of the whole cell, or some new method that where we make membrane potential identical everywhere in every neuron. So, you know, you can imagine cutting out, that's a beautiful way of doing it, you know, let's leave the transmitter molecules to do their trajectory across the
Yeah, but retain everything else. Yeah,
So once I pretend that it was released by the other neuron, but
Yeah,
it's not.
but it's not. It's released by.
Just for the purpose of this, you know, today's discussion, right?
Yeah.
So the point of this kind of a thought experiment is to make the situation as crisp and also as extreme as possible. And so, you know, thinking about possible, you know, empirical experiment or something like that, and its implication is also interesting. But by doing this kind of extreme kind of thought experiment, what we hope is to kind of pin down the core issue.
Yeah.
Like, you know, when Kyanshin said that, you know, genuine causation, right? What does it mean?
Yeah.
That's the problem, actually.
Yeah. That was what I was trying. That was my point, because I feel like you can release chemicals in the same way, and it's then the same like functional things, but is that still as unsatisfying as the neural disconnect, the axon disconnect rather?
Yeah, so maybe just to summarize what you were saying, right? By my guess is that when you said the genuine causation is that the A causes B through some kind of physical mechanism, and it's not the observation of the temporal succession of the event A via B, that is false causation. That's what you meant, right? Probably.
Yes.
And then but what's the difference between, you know, from the observer's point of view, what you are observing is exactly the same kind of events. Do you want to say something?
Wouldn't the cause and effect repertoire alter in this case? I don't have an in-depth understanding of IIT, but isn't that one of the?
Yeah, so I'm not a fan of like talking about causality per se. The key term for me is like intrinsic meaning or information, right? And the whole point of the reason I definitely jump off where the synapses are disconnected is simply because I don't see any way that, because there's no communication, how any meaning can be generated. So if there's no meaning, there can be no experience. And then this is why I also think it's a good idea to jump off at step 1 as well, because you're already sort of forcing this sort of lack of meaningfulness in the sense that nothing's actually interacting in order to create meaning. And then with regards to what you said about the cause-effect repertoire, yeah, this forcing the replay is affecting the cause-effect repertoire. And then the reason why I'm not certainly jumping off at 1 is because I don't know sort of how long we should consider this, how long of a time window we should consider this cause-effect repertoire. So this cause-effect repertoire is basically this transition probability matrix, and this sort of gives meaning to the state of the activity. So if we consider like a very specific time window where you're just replaying this and you're forcing this TPM to be very deterministic, then actually that means that the activity can have no intrinsic meaning in the way it's defined in IIT. I won't go too much into
Because
it.
it's completely deterministic.
Yeah, because there's no other alternative. And it's
Oh.
only through alternatives that you have.
Could you go back to the initial slides where you show the TPM, because not everybody is understanding.
about
Yeah,
this.
that one, yeah. So bottom right thing, that's the transition probability matrix. And maybe can you show the version where you have only one matrix? That's probably that one. So this basically shows that the column or row is the state of the neuron being on or off or something like that, and then the state of the neuron in the next time step to become on or off.
Yes.
So to come back to your question, right? Cause and effect structure in IIT is in a sense unfolded, or in their term, it's unfolded or reconstructed from this transition property matrix,
Right.
by thinking about what would happen if we force this system in this way or that way or that way, in many, many different ways, all possible ways actually. And then compared to that, what it is. That's a sort of the kind of thought experiment that IIT is doing within itself. But here, the step one, I mean, maybe I shouldn't actually say too much. So that's the sort of the cause and effect analysis that IIT does.
I guess my difference, so yeah, like I think this is the critical point as well. So IIT says there's this transition probability matrix. In a normally behaving brain, there's this evolving activity that evolves somewhat like probabilistically as determined by this. If you instead like force the activity to follow a particular trajectory, you remove like this TPM essentially, because like now it's just going to go, it's going to do this, then it's going to do that, then it's going to do that. There's no consciousness because there's no possible alternatives. And I guess my intuition is that TPMs aren't real in the first place because I'm more of a determinist about like either like it's got to follow a particular trajectory as determined by God, or it's like completely random as opposed to like determined by some quantum forces, but not in a way that's well described by a TPM. And so there's not really any difference between like what happens during the initial play in like the real brain, and then what happens when you're forcing the play. In that, like in the forced play version, it's still deterministic as determined by the previous activity, which is the same. And like as a result of that being my intuition, I have to go all the way to the end and say that the like person's still conscious, even when their neurons are distributed across continents, planets, whatever, because it's basically the same as it's step one anyway. But I could be convinced out of it if someone could really explain to me that TPMs are really a like causally fundamental thing, I guess.
Yeah, so for me, again, I think, and maybe this is like the cheating answer, but like not accepting the thought experiment in a way, but that for me, it's like if I would be convinced that during the recording, the person had a conscious experience and everything, like if I accept that, then I have to kind of follow through. But then I don't know, like it seems unintuitive to follow through with it. So now I'm just like, okay, how can I avoid accepting this?
I'm exactly. I'm just wondering, what about a version of the system's reply to the Chinese room, which would be you've transferred the causality to whatever recording device you've got that records the activity, and therefore the system that includes the recording device has now got the TPM.
Yes. Well, I feel the same way for the Chinese room, the distributed across China, I think NetBlock's version of this as well, where like my intuition, and I'm not a philosopher, it's very much intuition rather than formal description, is that like there is in a sense still some sort of causality. It's just shifted from like it's at the like neuronal integration level to like as was determined at some previous point in time that's still recorded in a computer database, but it's not like when you replay later with the neurons distributed across a whole different area, like they're still constrained by a system that had causality in it or still has causality in it at some point. And that for me is enough to think that I have the intuition that consciousness should still be there. So I feel the same with the Chinese room. It's like, well, it's like, yeah, the book with all the lookup table, like something still had to create that table in the first place. And when that happened, consciousness somehow went along with it.
So do you think consciousness is still there at step 4?
Yeah, I think it's there the whole time.
Okay.
At least that's my intuition.
But then if you would somehow enforce some kind of any kind of causal structure on individual neurons across the planet distributed, then that would create like a causal effect on those neurons, right? Like if you would just, like, I'm just trying to think about how can be the last version of the thought experiment. Is there a way how I could accept that, like not replaying another like recorded neuron activity, but somehow constraining that system that would actually create enough causal constraints, if that makes sense?
I'm not sure I fully understand, but maybe another way of
How do you think about it?
is like, imagine it's not replay. Imagine you've just taken someone's brain
Yeah.
and you've done the same thing, but you've kept all the like connections between inputs and outputs. So then now you've got this weird neural prosthesis that's distributed across, but it's still being fed in like information of me sitting here in this room.
Yeah.
Like you'd probably still think that was conscious, right? If it was still behaving like a conscious individual, even if you looked inside and you found that actually there was this computer, neuromorphic computer spread across continents running the body. Anyway, I'm sorry.
What would IT say about this, including the replay module as a system and then it's part of the causal structure?
I don't know. I need to think about that. But with regard, the more I think about it, as soon as you go into this fixed replay, I think IT probably immediately says no more consciousness.
Step one.
Yeah, step one. I think that's what IIT.
Maybe do you wanna go to the last part of your
Yes.
talk? Of course, maybe this is approaching to the issue. Yeah, maybe you wanna first share the screen.
What was that?
This one. Okay. This one. That's showing this one. That's fine. I think this one. That's not. That's great.
Okay.
Right.
For some reason yeah. By the way, that's the best discussion I've heard of. It's fantastic. We've got all the right people in the room to get every point on that. It's good not to have unanimity. So this is an extension now. I want to approach what I call the replay reply, which is basically for essentially the computational functionalists who want to say, well, a computation's a computation's a computation, and if we've got the computation, then it has to. That's all we need. And I just want to, before I do this, it's only a couple of slides, but just want to reiterate here, we're using what's commonly referred to as dynamic clamp for reasons that are important. So I just need to explain what a dynamic clamp is. This is a recording where you record with, and in the classic version, with one electrode what the membrane potential is, and you've got you basically can, that's just a detection device, and with another electrode simultaneously you're passing the required amount of current to achieve the change in the membrane potential that you're asking for. In other words, in this kind of an experiment, if the membrane potential is what you require it to be, then you don't pass any current. So if for instance, you just want to hold the cell at rest, then you do nothing because it doesn't need to be changed from the resting potential it's at. But if suddenly you needed to do an actual potential, you can just inject what you need, and you would monitor it the whole way such that you, in real time, alter what you inject to achieve what you want. And this is not a thought experiment. This is done on a daily basis in electrophysiology labs, and it really works well. In fact, you can do it with one electrode with pretty good electronics these days. but if you do it with two, you get the best possible result. And now let's go to, oops, so now I want to take this to a deterministic system. And just for the purposes, I've got 5 neurons, but this could be 100 billion neurons if you want. And we're going to assume that this is the system that's reporting that it's conscious. But it's deterministic because we build it out of components and so on. And that's important because what's going to happen here is we're going to we still have some input to this system, but basically the it's a computer. So I don't want to. What I'm trying to avoid actually here is the stochasticity of synaptic transmission, of channel openings, of all of the other things that you might claim are a little bit unreliable in the brain. We're going to absolute reliability. And the reason I want to go to that is that I want to push this to its limit, basically. So you've got the input, which could be the thing on the screen, conceivably, or just some input that you can do. And now let's just say as a computational functionalist, you have to agree at the beginning of this extension that for whatever reasons this is conscious. It's meeting the requirements of the computation, whatever that would be, that would give you consciousness. And now so the first step here is, like in the thought experiment, you give an input and it's conscious. Okay, that's prerequisite. Okay. Now in the second instance, you could do something like do it again, like give it the same inputs. And I think because it's deterministic, everything should be identical the second time. And so now you have to say it's conscious. Okay? So just twice the same input should give you the same result. Okay. Now we've been all the while recording from these neurons with a dynamic clamp. Now we get to an interesting, I think, dilemma, which is that there are 2 types of situations here. If I should have said, if you imagine you've got your dynamic clamp on this, and we now give, so we now go to the mode where we decide, oh, you can intervene now with your dynamic clamp, bearing in mind that in the dynamic clamp, you're only going to intervene if it's not what it should be. You've recorded what it should be. You give it the same inputs for the second time, which we all agreed, I hope, had to be conscious by the rules here. And now we've got an electrode ready, poised and waiting to alter the membrane potential if it deviates from what it should be. But we give it the same input, which makes it conscious. So we do, by the rules here, we do nothing because our dynamic clamp doesn't have to do anything. So then we have to ask ourselves, should that change anything? And one way of looking at this is that there's a set of counterfactuals, if you like, about what might happen under certain circumstances, which we are explicitly preventing. So we know we're preventing that, I think, because if you change the input, it will not change. And all of a sudden, you'd have to wonder why didn't it do what it did before? And it would suddenly be because you would have to, with your second electrode, with your dynamic clamp, you would have to intervene. So that's the proof that we're blocking a set of counterfactuals. But on the other hand, it does what it did the first time. And so you've got to, on the other hand, accept that that's not doing anything. Well, I don't know what you have to say, actually. Maybe I shouldn't prejudice. And then, of course, there's another kind of do nothing here, which is you could turn your amplifier off. So you've got everything where it was before, and you now prevent your electrodes from actually intervening. So I think, well, you tell me, but it's one example here would be that one conclusion here is that there is a difference between switching the amplifier off to do nothing and not switching the amplifier off to do nothing. and I'm not sure which way to jump on this. One thing that where I'll finish this and you can go back to the discussion. In some sense, I think there was in the replay reply, I'm imagining that there's a class of computational functionists that would say, well, wait a minute, the replay is the problem all along. That a replay is like a degenerate case where you now, if you go back to the initial slides, I don't know, I'll put it all the way to the beginning. If you go back to this situation here, you could imagine that the replay is degenerate in this sense, that it's a lookup table. So, and lookup tables have all sorts of problems, like what if we slow down the lookup? What pace should we do this? Or, you know, we wait 100,000 years before you go to the next step and so on. But there's all sorts of issues with a degenerate situation like this. And you could imagine the replay reply basically saying, okay, replays are out here. It has to do something in normal space in some sense that this is a excluded causality mechanism, let's say. And so then I don't know what such a person would say if we now do nothing in this situation and the whole system does what it does. So in some sense, it's replaying, but in another sense, it's just doing what it normally does. Or at least it's not so much that it's replaying, but it's that you're intervening to prevent any other situation than the replay.
Just to make sure everybody is on the same stage, okay? If you don't understand, just ask right now. So the type 1 nothing and type 2 nothing, you know, from the perspective of the experiment outside, what's happening is exactly the same, okay? In terms of the activity and time step and everything. The only difference between the two is that type 1 nothing is that there is a potentiality to make a change, but it chooses not to change, right? But type 2 cases, because you turn off the system, there is even no possibility. What actually happens is the same.
Just to clarify, you've proposed this as a way of putting pressure on computational functionalists, but I feel like it hits the IIT people just as hard because it is also the same situation where you've erased their TPMs in a sense, but it's still exactly the same naturally evolving biological setup. So
it doesn't hit you hard actually, because it has a principled answer actually, I would say. So I don't know. Do you want to say? Or do you want to predict what
I can see where Ariel's coming from.
Yeah, I know. Yeah.
Like, if you just replay the whole thing in like the whole physical world, right? The same thing is going to happen. So I guess that's where you're coming from. But I guess the thing about the TPM is it's sort of like the meaning of the state comes from, it could have been this or that or that or that or that, right? And then this one sense of replay that I've understood is that you kind of remove all these alternatives, in which case it loses meaning. And in the other case is where these alternatives still are there. Right. So you're playing the same TPM and it's taking the same path across states, but the alternatives are the same alternatives that they were before. So it's keep the same meaning.
Right. Can I clarify?
Yeah.
So let's say God hooks up his dynamic clamping system to someone during their initial experience and like sets it up so that like they know what the like first playthrough would be. But so we've got someone, they're like a naturally evolving set of brain states, and in that person, so it's not forced replay yet, it's just like this dynamic clamp system. Would IIT say that person is not conscious at that stage because they cannot have counterfactual states that neurons could enter into because of this dynamic clamping? Because that's what I thought IIT would have to bite the bullet on and say that like somebody is not conscious under that circumstance.
This dynamic clamping where like you observe and then intervene if there's a fluctuation, that's a new element that I hadn't thought about before. And with this new element, I'd be more inclined to set up IIT, in this case, would say that can be conscious.
Okay, that's
I would say that just to clarify your assumption, but I thought that you're in a sense adding more sort of the counterfactual possibility by doing this dynamic clamp and doing nothing, right?
Yeah.
You could actually intervene the system, but you are not doing.
Right.
Yeah. So in a sense, TPM itself is different. It's not, making it into deterministic.
I think it is.
I mean, replaying to make it like that is in a sense, but just by observing naturally what happens while you're recording and then not injecting anything is giving a TPM to be different actually.
But you're completely cutting off the counterfactual.
It's not cutting off.
But it is, because the dynamic clamp will stop it from taking any other trajectory.
I thought that you are not intervening anything, right?
But you would if it varied.
Well, you're not, it's not that it's that your device, because it's deterministic, that's why it has to be in the determinists. You know that your device won't need to, but you don't, but your device is sitting there ready to.
Ready to, right?
Yeah, so
Okay, if you can go to that slide. Yeah, maybe, yeah, so like one slide before, yeah, that one. Maybe I then misunderstood. So here, voltage clamp current for replay with the input. Is this the situation that you're talking about?
yeah, so if it tries to do anything else except for what you had already determined, like it should do through, like as per the replay, then it will force it to conform to what your replay is. Except in this circumstance, you're not actually actively forcing current into it. It's just was always going to play the sequence of conscious experiences you had in mind anyway. So the
You're
equivalent.
claiming that the TPM has or hasn't?
I'm claiming the TPM's gone because you've prevented it from having any counterfactual states. And I think IIT should say that it's not conscious at that stage because there are no counterfactual states anymore.
But what I'm saying is that it's different. I'm saying that the TPM will be not completely deterministic, at least as undeterministic as the original system, but it may have actually even additional kind of structure because other people can intervene things. So even if you play the same game once, then if you don't do anything, then the system itself may actually play a different way. But you said also there is some kind of removal of the ion channel fluctuation and so on for this. So
For these thought experiments, it's a mechanical system. It's a computer where all the components do exactly the same thing every time.
I see.
They get the same inputs. Only so that I'm only doing that because I want to prevent the escape mechanism that many people might think of, which is ion channels are stochastic and snappy transmission is stochastic. So you should never expect your amplifier to be in a situation where it does nothing. So I want to first of all put myself in a position where it's possible that your amplifier doesn't need to do anything, and then ask, is there some difference?
Because then maybe I don't know. Maybe we can talk about it later. But different way of posing the same kind of question is that if we have a capacity to attach this kind of dynamic clamp system to our brain, for every neurons, for a moment, then at that time the causal mechanism starts to involve not only the brain but also involve something external as well, and that will change the TPM of the brain. And I'm not saying that that will completely eliminate consciousness, but it will just change it.
There's also, I think, another escape mechanism no one mentioned, which is maybe the noise is quintessential, or maybe the noise is the possibility not to be the same every time, and that's somehow really intrinsically important.
Yeah, so that's something that you also alluded in the last comment, right? Actually,
Yeah.
And this is also very, very fundamental also to IIT as well. Actually, I don't know whether you talked with Giulio in Italy, but
But not about noise.
okay, so uncertainty or probabilistic mechanism is very, very essential for IIT. If everything is completely deterministic down to the bottom, then it doesn't work, basically.
Yeah, that's how you get me to get off at step one. If
Yeah.
you somehow show the noise was like crucial, then
Yeah. And then in terms of noise or determinism, I don't know whether it becomes a bit far from this kind of discussion, but it's going to be probably very, very important to start think about, causality and so equivalence class, and also the framework of science at the same time, actually. This is coming from really old argument by David Hume, who started to talk about the causality very, carefully in the history, right? And his one of his points is that to give an explanation about causal mechanism or causal laws or causal observation, whatever, you need to assume that things that you are observing or talking about is exactly the same state in the first place, and then that transits to another thing, right? But to what extent you consider something as same is on the eye of the beholder. Equivalence class.
So now you brought up that, I want to put this another way, because when I got to this point, it felt to me that this is no longer about consciousness. This is about reality in some sense. Suppose you have just a bog standard calculator, and in this, and well, actually, let's compare this to a calculator. Let's say that works on a neural network. Just so it's inside, just so we can really make an analogous. It's a bunch of neurons that do whatever they have to do, but it's as reliable as a calculator as they're normally done. And let's say you type 5 plus 6 equals, and it pops up and says 11. Okay, and then let's say along these same lines, we grab hold of every neuron in that. We do the replay basically, and now you're the woman now pressing 5 plus 6 equals, but now it's doing 11 because of your replay, so it's everything there. Okay, now you type 5 plus 5, and it says 11. Now, the question I have is the step before this. Did the calculator calculate 5 plus 6 in the case where you made it go to 11 regardless, which you can prove because you said 5 plus 5 and it's 11. Did it calculate 11 the step before? Or did it not calculate 11 because you made the neurons do this? I mean, what did the calculator do?
Yeah, so that's sort of in a sense, question about what is computation, right? In this, in the words of this slide. And I think that computation in many physical systems is transition of the state to another state in a reliable manner, as you said, right? And this reliability in this sense is on the eye of the user, right? From the user's point of view, even if the state of the electronics are slightly different, it should not matter. And then all of these kind of temperature difference or state of the pressing, half pressing or whatever should count as one, and then that goes into another state. That's what matters for this calculator or computer and the computation. But in the case of the brain, what matters as the same state or same moment or same kind of causal effects and so on is very difficult to understand, right? Especially because we don't have an exact, repeat of the same state of the system every time. As you said, brain actually changes moment by moment. So we don't have any kind of, real example where we know exactly how the thing actually behaves in one way to the other. And if you start really thinking about, down to the bottom, then quantum effect has to actually come out at some point. I'm not saying that the quantum computation is there in the brain, but more like, even the molecule level, when you start to actually measure things, then the measurement itself starts to, have an effect on the micro things. And that will be very, very problematic to determine what the state of the system itself is from the quantum, kind of thinking. So all this thinking about what could be the state for a particular TPM and what could be the meaning of this causality or effects over the time in the reality, it starts to become very difficult to argue for something like a determinism, I would say. Well, before that, maybe.
I have a less sophisticated question and comment. So regarding this computation, can I consider like this kind of functional connectivity to be one of the examples? Because from my understanding of functional connectivity,
Functional connectivity is just observed correlation.
yes,
okay?
that's what I'm trying to say.
Right.
So functional connectivity is like 5 and 6 and here 11, and then let's kind of infer that 5 and 6 are connected to produce 11,
right.
but it's all inference.
Right.
So that's what Matt is talking about here, right?
But you also talk about the structural connectivity as well, right? The diagram over there is a mechanism. That is an actual connectivity.
It's like they're actually axon.
Yeah, E is sending something to A, right? That is different from functional connectivity. Functional connectivity is just recording A, C, D, B for a long time and they infer that direction.
Yeah,
But if we observe this physiological mechanism, that's different.
in the sense that we understand, like the reality, a lot of the mindset of doing these kind of neuroscientific studies is that I assume that because I see the correlation, I kind of infer that they're causality, but they don't actually go and verify it. So for these people, your thought experiment would be very problematic in the sense that, well, I mean,
For which people?
the functional connectivity in a sense, right? Because you recreate the correlation, but without adhering to their assumption.
I mean, we can go back to kind of David Hume here, can't we? If you have 2 billiard balls and you throw one at the other and it goes into the pocket, and then you get somebody to hold the second billiard ball and you throw it in exactly the same way, and the person holding the billiard ball throws it into the pocket. You could ask, did the first ball cause it to go into the pocket the second time? Or did the person throw it into the pocket the other time? And where's causality here? Who do we attribute this to? In some sense, particularly if you tell the second person holding the ball, do exactly what you ought to do if this would be a causal influence. So they observe the trajectory of the first ball and they say, oh, that's online. I'll throw this into the pocket. So did the first ball cause it to go into the second pocket?
Both of these components is actually really important, but we haven't actually talked anything about this kind of thing in the lab meeting. The key here is probably the concept of the do operator kind of thinking in Julia Parr's causality analysis. What you're saying about holding the ball is basically a do operator. Just removing any kind of cause for this to the this effect from the past, and then just disconnect everything in the past or upward stream, right? And then just start from there. Then what happens? And IIT is also doing the same thing. Do operator on each of the neurons or the set of the neurons at the same time. Do operators forces the system into one particular state and also action. And that's a very different way of thinking about causality. Just observing and then inferring, like you said, is has a lot of problem indeed. But Parr also discovered in some situation that can also lead to the real kind of causal mechanism as well. But in this kind of recurrent and connected situation, it's not possible. Anyway, you wanted to say?
I could talk about this stuff for days. So
In the sense, some of the causality that people are trying to study here is the kind of, it's illusory in a sense.
What do you mean
It's
by
like
that?
well, because it's more useful to say that these two correlated regions are connected, then let's assume that they are kind of connected and then study it that way.
I don't know what you're trying to say, but are you starting to claim that people should actually do this kind of do operator kind of operation even in psychology or neuroscience, or?
No, it's well, I'll think about it a little more.
Is there any comments from also the Zoom audience? If you have any questions, you can also raise a hand or chat, type in chat. But otherwise, Aniko, you have a question.
Yeah,
Okay.
maybe, yeah, if Daisuke wants to talk, then I can leave.
Yeah, maybe then Daisuke first.
All right. Thanks for the very nice talk. Very interesting. I actually had a question on the people in the room about the first part of the talk and the first step of the experiment where the cause and effect structure is lost. I'm just curious, according to IIT, what the experience of the subject is like? Is it just like feeling nothing, or it's just black experience, or what does the IIT predict about the phenomenology? That's my question.
In the step one.
Yes.
I think probably the consciousness will be completely lost.
They have an
That-
absence seizure.
But I don't know. Can you also put the slide again? Step one. I
Distributing the recording.
Yeah,
no,
step
that
zero.
step is zero, right?
the replay.
Where should I go?
To the second, the step one thing.
Step one's the force replay with the voltage clamps.
Step one. Page 8, yeah, that one.
Yeah.
Right.
Yes, displays.
So that's good. I think that here, because any kind of causal interaction from A to B is already eliminated. It's forced, and it's the same thing as a lookup table for IIT. I think I could be wrong, but that's what I imagine. Wait, maybe then depend.
Can I understand like this? If in step one we have consciousness, which means that if we play everything in reverse temporal order, there will be consciousness, but I can't imagine like that. So based on the IIT theory, there will not be any consciousness in this step.
Reverse in temporal order.
Yeah.
That also removes the causality, so
Yeah,
it doesn't matter.
So yeah, that's what I want to explain this your point to this.
No, my point is even in the forward order, let's say if A fires and B fires, but like Matthew said, it's almost like holding this B ball by hand, and then A is firing, and the B is now firing, but this hand is fired.
The pathway is deterministic, right?
But yeah, in this case, yes.
Yes.
Deterministic or not is less of the problem in here, but in the step zero case, this is actually hitting, and then this ball is moving. But here, you are moving this ball, and then this ball is now moved by your hand.
Get it, yes.
So it's a separate kind of causal mechanism. And here, the brain doesn't involve this causal structure. So I would imagine, in response to Daisuke's question, they will lose consciousness. Fine, Daisuke?
Yeah. Interested to hear. Thank you so much.
And then, wait, another question from Steve.
Yeah, hi. Really interesting listening to this discussion. I wrote a paper about 10 years ago that was fairly similar, but had a different intention, in which I was trying to ascertain if we could stimulate neurons, stepwise inhibit them, to try and get at the neural constitution of consciousness as opposed to the broader set of neural correlates of consciousness. I'm not sure if you're aware of that paper, Matthew. It's similar in many respects, but it wasn't sort of addressing this issue of computational functionalism. Anyway, that part's a comment, but the question is where I got to was with that work is that you couldn't do it. You couldn't get to the neural constitution of consciousness from the broader set of neural correlates of consciousness by having control over neurons, the way your thought experiment also postulates. And I think this speaks to the broader problem, which is, how are we going to know? How could we ever know whether all those neurons in different labs all around the world, all set up to fire at the appropriate time, was or was not conscious? It just doesn't seem like we can get to ever understanding whether that set of neurons operating that way is conscious or isn't. Is that something you want to address?
Yes, so now you brought that up. Let's suppose that it's you, Steve, doing this experiment, and there's all the electrodes are on your neurons, and you watch the screen, and then it's all done. Is that, are you imagining, or do you conclude that you would be the one person in the world who'd know the answer at this point? Because
you can't take all of my neurons and put them in separate labs.
No, sorry, I should have done this. No, I'm talking about step one. So let's suppose that step one, so nothing has changed except, of course, there's a lot of hardware in your brain. But given that we could do that, or there's some magical way to do it without glass pipettes, it's effectively your brain is really intact. And I'm not sure actually, the more I think about this, that you should conclude that you would know in this instance, because one possibility is that what you do is you have a blackout basically, but you have a blackout and come back exactly where you were. And so now if I want to do this properly, I want to put a clock on the wall that is tracking time. And if you have a blackout, then your experience, I think, is that you see time go, you see the clock just go, a few seconds forwards. But maybe I don't know what the answer is here.
I think that would break your experiment, because the idea is if you got exact replay, you'd see the clock and then you just instantiate yourself after the blackout with the memory that you're right at the time. So it's unreportable whether you're absent or not.
Is it? I mean, but it could be that we're unconscious.
Yeah, but at the end, so you've been unconscious for the time, and then you get put back in at the end state.
Yeah.
And then in that end state, from then onwards, now you're able to vary, but your memory state would still be on.
Oh, I see what you're saying.
It was.
So if you were conscious, you would go back and you would think you went back in time, but you wouldn't, and then you would see the clock differently at the end of that. And if you were unconscious, you wouldn't think anything, and then you would see the clock.
Yes.
Yeah.
Also because it wouldn't form a memory or like that.
So I'm saying either way, you'd have the same memory state at the end, whether you were conscious or not, because you just have the memory state of whatever happened at the end of the replay.
Doesn't that make you see the clock just go a few seconds further? Jumping. Yeah. It's like,
I don't think so, because the idea is if you've recorded the whole time initially, then you'll have the same replay, and then at the end you'll see the same thing.
But
Like,
then I think that's
happens after that.
one step.
after
like
you
are
come back.
But you still have the sense of time. So let's say like just before the recording starts, you look at the clock and it's 12.
Yeah.
Then you record for 10 seconds,
Yeah.
and then you allow it to vary again.
Yeah.
If you're unconscious the whole time, and then you're brought in at that end of the unconscious period, you'll still have the feeling that 10 seconds had passed. So you look at the clock, because the last memory state of the initial recording was you felt some time passing. So if you're unconscious, it doesn't matter. If you're conscious, it doesn't matter. You can't tell because the state's the same at the end.
Normally, if the type brings to you wouldn't feel.
But it's not turned up. It's still following the same trajectory. It's just
Yours is
unconscious.
Phenomenologically,
Yeah.
phenomenally conscious of it.
I would
I'm fine with still continuing the discussion there. But then Then I'll just say one word. So it's not exactly the same kind of experiment, but if you have read a preprint of this, register, I think it's a pre-registration still of the adversarial collaboration in the third round, which is to compare the IIT and the predictive coding and predictive coding with inference and so on. Then the first experiment that is doing something like that, or trying to do something like that. So what it tried to do is that within the visual cortex, they first identify the neurons that do not respond when the mouse is presented with this kind of two stimulus on the display. Okay, maybe this one, and then mouse is trained to poke the location of the center of the gravity here, right? In this case, but then in some trials they try to silence, or in this case, it's kind of active dendritic active clamp, dynamic clamp, to make the silent neuron impossible to fire. So that basically just kills the causality, but without changing the activity state. Okay, only for 200 milliseconds. And then within this 200 milliseconds, I think the pulse of the image is just like 50 milliseconds or something. And then later on, mice is supposed to poke the nose to the place of this, center of the gravity. And then if you are, if you are following IIT's prediction, then inactivating this already inactive neurons should alter the visual experience. So then the mouse would probably poke into something really weird. But if you are following this kind of predictive coding type stuff or usual computational functionalism, then the activity states and computation should be the same. So they will poke the same location.
I guess I would say that I think it might alter their experience, but it can't alter their behavior.
Yeah, I mean, if the state of firing is the same, then the same motor neuron will fire and they will poke exactly the same spot.
That's basically the same kind of question here.
Yeah, I mean, yeah.
So it's not the entire, this is very, very, elegant and extreme kind of, thought experiment, partially that kind of thing can be addressed. I mean, that's the reason why I wanted to kind of reply to Steve, but.
Did you want to say something about that, Steve? With the protagonist?
I don't know whether it will answer to his question or not, but.
Well, because I understood Steve to be saying, well, we can't even know. And I'm thinking, well, there's one step in this whole thing where you, principal, could know, but I'm not sure you can know. I think you're saying you wouldn't know.
I'm saying you could know, but you could never report it in any way, I guess. Is sort of, was in like, you could be conscious during the period, in which case, I mean, I would write it out more formally so that you can see, but basically like you do the replay, in the middle of the replay, if you're unconscious, you can't report it. If you're conscious, you can report it. But at the end state, you just like reach the end of the replay, and then it's the same either way, whether you've been conscious or not the whole time.
And what does it mean to say you don't know if you were conscious? It's that in this case, you're saying, I'm not sure whether I was conscious or whether I've just been forced into a replay and jumped in time.
This is actually like very similar to the substitution argument that Eric Hull and Johannes Kleiner have talked about at length. I think this is like an informal version of what they run through in detail.
And does this go at, I mean, the Tononi core assumption that that's impossible, that we're not allowed to go there, that we don't know if you're conscious?
I don't know, but if you're really, really rigorous and precise, which is very critical for this kind of thought experiment, is that also you are assuming that at the end of this replay, of this inactivating inactive neurons, the neural connectivity plus state is exactly the same in two situations, right?
Yeah, isn't that I feared? Like that's what the experiment does.
Yeah, for the empirical experiment, it probably will, I think, because there is some kind of causal effects of even inactive neurons. the end result will be slightly different in some way, so that phenomenal experience during this inactivation is probably reportable, I think, empirically, because also the inactivation is very partial, unlike Matthew's experiment, right?
Yeah.
But yeah, if the state of the neurons and the connectivity is exactly the same, then I think including memory and potential experience, that has to be the same.
Yeah, exactly.
If you're recording all the entire brain state, are you also recording the state to report as well? And if you're replaying it, are you just replaying their report? Like if they're pressing a button,
That's nice. Yes.
like
yes,
aren't you
so-
just replaying the same, like, I don't know, descending
Right, the
motor
first way,
neurons?
I think in the first formulation of this, yes, you actually continue the recording while the woman says,
I see it.
and puts her hand up, says, and that was a conscious,
Yeah.
subjective experience,
Mm.
and you record it,
Mm.
and you force her to.
Yeah, because then it
to-
returns to the
do
billiard
that,
ball sort of
yes,
thing.
And then, right, and then, so you get the report and everything. And that was necessary for the third person. For the first person,
Yeah.
you probably want to just cut it off before that.
Cut it off before any report.
yeah.
So then I think like then it goes to Aru, where it's like if you replay that, you just end up at the state at the end pre-report, and then
Yeah.
you don't feel like
Yeah.
any difference. But if you include the recording of saying like I have a conscious experience, then it's the billiard ball where you just replicate the like reporting it without actually being maybe
Right.
consciously aware of that.
The delicious thing about this thought experiment when you do it from the first person is that it avoids this billiard ball problem.
Yeah,
that
exactly.
You're in the billiard ball now. You're asking, did you experience, is there an experience associated with this causality?
Guess it ends up the same as like, am I a Boltzmann brain style
Yeah.
thing?
Right, and I guess that what way you construed this, I think, is kind of, you could posit, what if we're all just instantaneously here now? It's all been arranged and there's no ongoing process. So this is something I also didn't understand. I had to admit in Venice, just because I don't think I've got the capacity to do this. Some people seem to do, there's some really intelligent people that are talking about timing and processes and the extent to which time plays a role in this whole thing.
Right.
And I lost the plot at this point and didn't understand.
I see. But what you said just last minute, this the moment of experience is exactly defined by now. That's very fundamental assumption in IIT. And many, not many, but some of the anesthetic kind of drugs actually have such a phenomenological report, right? Like when it kicks in, it's completely, eliminates anything, and then you are just come out of just before the anesthesia kicks in, and then you lose that. It's literally like an edited out kind of experience. You go in and then come out kind of thing. But then in normal sleep experience or different kind of anesthesia, you have a sense of the flow of time, even at the kind of reduced thing. It's very different kind of state of the brain. And yeah, I think, IIT always think that moment of the experience right now has to be experienced by the current state and the current connectivity. And if you can, mess around with it in principle. Okay, maybe it's probably a bit over time. So I want to thank Matthew and for the question. I'll then just stop the recording now.